In this unit, topic 3, you will see the relationship between pressure and volume for a gas at a constant temperature, and then also look at something called Boyle's law, which is a mathematical equation that relates pressure and volume of a gas at a constant temperature. In order to understand pressure and volume relationship, you need to understand the kinetic molecular theory. Now this was explained earlier, and it helps us to understand the relationship between a gas's volume, temperature, and pressure. These three quantities will be explored in the various gas laws that you study in this unit. In this topic, topic 3, Boyle's law, we're going to look at the formula that is used to calculate pressure and volume changes for a gas at a constant temperature. Robert Boyle was a scientist who did some work with pressure and volume relationships, and he noticed that if you double the pressure, in other words, you make the pressure twice what it was before, on a sample of gas at a constant temperature, the volume of that gas was reduced by 1/2. And the kinetic molecular theory explains this, where we see the pressure of a gas is caused by the molecules of that gas moving around and then hitting the container walls. So if the volume of a gas is decreased, then you'll have that same amount of gas moving around but colliding more in a smaller volume. And then therefore, with more collisions, you have more pressure. The same way, if the volume is increased, so the gas is allowed to be in a larger container, you have fewer collisions and therefore less pressure. Boyle's law states that the volume of a fixed mass of a gas varies inversely with a pressure at constant temperature. Inversely means as if you increase one, then the other quantity goes down, and if you decrease one, then the other quantity goes up. So you can see the graph of data relating volume and pressure of a gas shows a curved line. So this is known as a curve graph or hyperbola. Mathematically, Boyle's law can be expressed as pressure times volume equals K. The pressure is represented by P, volume is represented by a capital V, and they use K to represent a constant. You'd think they would use C for constant, but as you remember, C is used for the speed of light, so they just use K as a constant. So P times V vary inversely to get their product, in other words, multiplying them to be a constant. So if you increase the P, you have to decrease the V in order to get the same K value. Because two quantities that are equal to the same thing are equal to each other, Boyle's law can also be expressed as P1 V1 is equal to P2 V2. So this is the formula for Boyle's law. P1 and V1 are used as the initial conditions. So that will be, you'll see later on, there'll be the initial pressure and volume given to you. And then P2 V2 will be the new pressure and volume after something has changed. So if you have 3 of the 4 variables given to you, you can rearrange the formula to solve for that 4th one. So let's look at some example problems. The first one, a sample of oxygen gas has a volume of 150 milliliters. So you see that that is the first volume given, so that'll be V1. When its pressure is 0.947 atmospheres, so that's the first pressure given, so that would be P1. What will the volume of the gas be? so that will be V2, at a pressure of 0.987, so that's the second pressure given, so that'll be P2, if the temperature remains constant. You rearrange P1 V1 equals P2 V2 to solve for V2. So if you just look at that algebraically, you'll divide both sides by P2. So you end up with V2 is equal to P1 V1 over P2. So two ways you can solve these problems. You can plug the numbers in and then solve it algebraically, or you can rearrange the formula using algebra, plug the numbers in, and then that'll tell you what to multiply or what to divide. So for this example problem, we plug in the P1, the V1, and over the P2, and using sig figs, notice that the atmospheres both have 3 sig figs, the volume has 4, so since we're multiplying and dividing, you go with the least number, so that will be 3 sig figs. And keep in mind that the volume label will be the same as the volume label for V1, which would be milliliters. So let's do another example problem. A sample of hydrogen gas has a volume of 250.0 milliliters when its pressure is 0.749 atmospheres. What will the pressure of the gas be if the volume is increased to 500 milliliters and the temperature remains constant? So you can pause this and work out the problem and then continue the video with the solution given to you. So if we start with P1 V1 equals P2 V2, rearrange it to solve for P2, we divide both sides by V2, so P1 times V1 divided by V2, plug the numbers in, round your answer to correct sig figs, which would be 3 sig figs, and then the pressure label is the same as the original pressure label. If you would like to do some additional practice problems, you can turn in your textbook to the very back of the textbook and look at problems 237 through 241. You can try these out, and the answers are on the next slide, so you can pause this and work these problems out if you prefer, and then check out your answers. Ask your teacher if you have any questions as to why you didn't get the right answer. So now you can take the Schoology quiz relating to Boyle's Law, pressure-volume relationship, as well as the other resources in this folder.